Hey everybody, today what we are going to be talking about is the sine rule. Now just to review a little bit from the past, before we have talked about the cosine rule. The cosine rule is when we are looking for a missing side or maybe a missing angle, and we're given the information of either two sides and an included angle or all three sides. We use the cosine rule, which we've gone through the proof of that and how that was developed, how that formula was developed. And now we're going to look at the sine rule. The sine rule is when we have a slightly different information, two sides and a non-included angle, or two angles and a side. Now these again are using this non-right triangle over here on the right. This is where we have our three angles A, B, and C, and our sides opposite those angles are measured in little a, little b, little c. So what we are going to be looking at are two sides and a non-included angle. So maybe we've got these two sides and we have this non-included angle. Or maybe we've got two angles and a side, and we're trying to find one of the other sides or one of the other angles. Now where this comes from, how we're going to develop this sine rule, is we're going to look back at the area of a non-right triangle. Right triangle. And if you recall, that is 1/2 AB sine C. So that was our original formula for the area of a non-right triangle. So that would, if we're looking at this triangle over here on the right, that would say A, B, and sine C. Sine C. So there we've got two sides and an included angle. But our sine rule uses two sides and a non-included angle, or two angles and a side. So how do we develop this? Well, this doesn't mean that we can only, looking at this triangle or this area formula, it doesn't mean that we can only do it with sine C. We could also do it with sine B, and we could also do it with sine A. It just depends on what information we're given. So we could look at technically three different ways to write this. We could have 1/2 AB sine C, as we just saw, or we could have, let's see, I can do this in some different colors here. Then we could also have 1/2 BC sine A, so BC sine A, or we could have 1/2 AC sine B. So those are the three different options that we could have with our two sides and our included angle for the area of the triangle. But we're not looking for the area. We're looking for missing sides and missing angles. But we know that because of the relationship of the non-right triangle, all three of these equations, this one, and this one, the red, green, and blue, they're all equal to the same thing. They're all going to get you the same area of the same triangle. So what we're going to do, just like any equation, this is kind of a triple equation here, we're going to isolate some information. So we are going to divide everything, all of our sides. In this case, we've got three different equations, but they're all equal. So we're going to divide everything. We're going to divide everything by 1/2 ABC. So we're not changing anything because we're doing it to all of our sides. And we're going to see what happens when all of this cancels out. So in the first equation, if we have the red equation, if we have 1/2 AB sine C divided by 1/2 ABC, we know that this is going to cancel out, that's going to cancel out, that's going to cancel out. In our green equation, that's going to cancel out, that's going to cancel out, that's going to cancel out. And in our blue, there we go. So what do you recognize that is left? Well, it doesn't take much observation to see this, that on our red equation we have sine big C is related to the little side of C. Or we've got sine A is related to little a, the side A, and we have our B, our sine B is related to the little sine B. So what this is saying is all three of these fractions are exactly the same. And you'll see here in a moment how we can use each one of these to help us find different area or different sides and angles. Okay? So here's what we're going to do. I'm going to actually move this down a little bit, and we are going to work on this problem here, and we're going to work on this triangle. We are going to try and find the area and the perimeter of this triangle. Okay, so we've got A, B, and C, the angles A, B, and C noted, and we see that little c, this would be little c right here, is 12 meters. So we know that this is going to be little a and this is going to be little b. If we just go back to the same triangle that we started with, the non-right triangle. So let's pop in some of the values that we know. So we know that sine c over c is the same thing, or it's equal to sine b over little b. So we're going to take our values, we're going to plug those in. So sine c, sine 39 degrees over 12 equals sine of 58 degrees over little b. So we do our magic, we do some cross multiplication, do some calculations, and we are left with, what are we left with? We're left with 0.62932 over 12 equaling, I'm not going to bore us with all of these calculations, but you can do this as you go, as I go along. Try this on your calculator over b. We do our cross multiplying, so we cross multiply here and we cross multiply here, so it ends up working out to be b equaling approximately, let's actually do our approximately sign in here. B is approximately 16.17 meters. Okay, so we've got 16.17 meters. All right, so now we need to find side A. So we want to find the area and the perimeter. So let's do side A. All right, so side A, might need the picture here. Side A is going to be, well, actually we can find angle A to begin with. That might be helpful. So angle A, that's just going to be 180 minus 58 minus 39. We know 180 degrees in any circle, so we're basically subtracting out the two known angles, and we're left with 83 degrees. So we know that this is going to be 83 degrees right there. So now we need sine A, or side A, excuse me, side A. So let's just take this piece right here. We already know what that is, so we're going to have 0.62932 over 12. So that's basically taking sine C and side C, and we're going to make it equal to sine 83 over little a. So we do our cross multiplying, we do some calculations, and we get A is approximately, side A is approximately 18.93 meters. There we go, 18.93 meters. All right, so now we actually have to find the area and the perimeter of this. Let's see if I can copy this and move it down out of the way here. So we're going to take this and we're going to drive it down here, and let's see what we've got. All right, so the area, let's start with the perimeter. The perimeter is nice and easy. The perimeter is just going to be all of these sides added up. So we've got 12 plus 16.17 plus 18.93. So our perimeter is going to equal approximately 47.1 meters. All right, nice and easy. And now our area. What is our area going to be? Our area is going to be equal to 1/2 sine, or 1/2 AB sine C. So you could use any of the formulas that we've been talking about, but we'll do 1/2 A, which is 18.93, B, which is 16.17, times sine C, sine 12. Sine C, I'm sorry, nope, sorry, not sine 12, sine 39. Sine 39 degrees. So again, just punching this into your calculator, you'll get that the area is approximately, let's get a good approximation in here, is going to be approximately 96.3168, or we can just say 96.32 meters squared is the area of the triangle. So that's how we use the sine rule to help us find missing sides and angles, and then to build into area and perimeter. Hope that helped. We'll talk to you soon.